So we're going to apply some of this ideas about sets and subsets to what we call the real number system. So every number that you see in elementary school could be a fraction, a decimal, a big number, a small number, a negative number, a positive number, and every number that you're going to see in high school is a real number. So real numbers are every number that you're going to come across from grade 1 to grade 12, and we're going to denote that set with the symbol R. So R is the set of all real numbers. There are also numbers that are imaginary. Maybe we'll talk about those on a Google Meet, but you won't really come across those much in high school math. So we're going to deal with the real number system. And we're going to break up the real number system into different subsets. So the first of which we're going to call the natural numbers. The natural numbers are things that you can count on your fingers. So on your fingers, starting at, first of all, we can only start at 1, and we're going to count things that we can see, and we're going to use the symbol n. So we're going to use our set notation. The natural numbers, we're going to use our curly brackets, and we're going to separate each element with a comma. So I'm going to start at 1, 2, 3. So there are only numbers that are positive, no fractions, no decimals, things that I can count. And this is an infinite set because it goes on forever. I can keep counting. So I'm going to use those ellipses, so 3 dots, to say that the natural numbers go on forever, 1, 2, 3, and so on. So the natural numbers are a subset of the real numbers. If we add 0 to the natural number, we get a new set that we're going to call whole numbers. So whole numbers are really similar to natural numbers, but it's also going to include 0. So the whole numbers, the set W, is equal to 0, 1, 2, and 3. So whole numbers, there are no negatives, there are no decimals, and again, it's an infinite set. Now, when we also add negative numbers, you probably already know this, the expanded set is called integers. So integers might be the numbers on a thermometer, the numbers on a number line. So integers, maybe -5, -4, -3, -2, -1, 0, and I could keep counting up. So it includes all the natural numbers, 1 and higher. It includes all the whole numbers, and now we're also adding the negative numbers. So what's interesting is that the set of integers, I've got to add these 3 dots in both directions, because I can go all the way down. It keeps getting, if you think about a thermometer, it gets colder and colder and colder all the way down to negative infinity. And it's also an infinite set in the positive direction. I can go all the way up to positive infinity. So that's the next set, are the integers. So I'm going from small to big. There are more whole numbers than negatives because I'm adding 0, 1 element bigger. And then integers are infinitely bigger because I'm also adding all the negative numbers. If we can write a number as a fraction with a numerator and denominator, we call it a rational number. And we're going to denote that with the symbol Q. Why can't we use R? Well, because I'm already using R for real numbers. And the next letter in the alphabet after R is Q. So we're going to use Q for rational. So any decimal you can think of that repeats. So for example, 0.3 repeated is the same as 1 over 3. That's a fraction. So we could call that a rational number. 0. I don't know, we could think about 1, 1, 1, and it repeats. That's 1 over 9. Any decimal that repeats is a rational number. 1 over 7, that can repeat. So it might take a while before it starts repeating, but I've got 2, 8, 5, 7, 1, 4, and then all those numbers repeat. So if it repeats, that means we could write it as a fraction, and it's rational. If the decimal terminates, 0.5 is 1/2, 0.8 might be 4/5. Anything that we can write as a fraction is a rational number. So decimals, maybe 1.3, so that's 13 over 10. So if we can write it as a fraction, it's rational. So that includes all of the natural numbers, because I could write 4 as 4 over 1. It includes all of the integers. So rationals are our biggest subset yet. And then our final one, we're going to call irrational numbers, which are the opposite of rational numbers. So if a number is irrational, it's not rational. So that's a decimal that goes on forever without repeating. You might know some numbers like this. A lot of them are very useful in math. So for example, pi is an irrational number. It goes on forever without repeating. E is another one. We can talk about what these mean and why they're useful. Actually, the code of our Google Meet, which is tau, is another irrational number. It goes on without repeating. And we use Q bar, and the bar means it's not rational. So it's not a member of the set Q. It's set Q bar. And this is another infinite set. So all of these sets are infinite, and they're all subsets. All 5 of these subsets fit within the real number. So at the bottom of this page, if you imagine that this box is all of the real numbers, the smallest group here are my natural numbers n. So for example, 3 or 8. So it's a smaller box inside the real number system. And the next smallest is whole numbers. And it's kind of like they're all nested. So natural numbers are a subset of whole numbers. The only numbers that the whole numbers add is 0. It's the only extra element. So natural numbers, any number that you can count, positive, no decimals, no fractions. Next are the integers. So the integers include all the natural numbers and 0. But now we also have numbers like -3, -42. And all 3 of these boxes are rational. And so are any fractions or terminating decimals. Terminating means ends, or repeating decimals. So those are all my rational. So rational is the biggest subset yet. It includes natural, wholes, and integers. Now, irrationals are the other part of the real number section. So anything in this box to the right is not in the box to the left. So irrational numbers are numbers. They're not natural, they're not whole, they're not integers, and they're not even rational. And we can think about a number like pi, e. If you tried the square root of 2 in your calculator, this is a fraction that's going to go on forever. It's never going to repeat. And we call those the irrational numbers. So these are 5 important subsets of the real number system: irrational, rational, integers, whole, and natural. What I'd like you to do is make sure that you can define each of these subsets and then come up with your examples. If I give you a number, you could say, well, which subset is that part of? If I gave you -8, well, that's an integer. It's rational because we could rid of the fraction, and it's real. But it's not a whole number, it's not a natural number, and it's not irrational. Okay, that's all for now. You're going to try some practice with sets and subsets and then all these different categories of numbers. Okay, thanks for watching.